Hey everyone, how goes it? Welcome to Computer Science 146. Today, we're going to review computers. Now, there is a large misconception that what's inside of a computer is something that is magical. But that's absolutely not true. It's just a tool. It's a tool for us to solve problems. But while what's inside of it really isn't all that magical, what you can do with a computer absolutely is. In order to make this simple, we're going to abstract a computer as some kind of device that accepts some sort of input, computes something, and then creates some kind of output. Simple enough, right? Now, going from that abstract model, a computer has two major sets of components, the hardware and the software. Now, going into a little more detail, there is a lot of hardware that's associated with computers. But as programmers, we're only going to concern ourselves with a couple of pieces. Two of the major parts is the CPU and the memory. Now, the CPU, or the Central Processing Unit, can be thought of as the brain of your computer. This is the device that is running instructions inside of your system. Now, it only understands very simple instructions, in other words, zeros and ones, but it is essential to running software. The other piece of hardware that we're going to also focus on is memory. Now, when I refer to memory, there are some categories of memory. However, I'm referencing the primary version of memory called random access memory. Now, this is different from secondary memory, in other words, a hard drive, because random access memory is volatile. It temporarily stores information, including the program as it's running and the data associated with the program. But as soon as the computer is shut off, all of that memory is wiped out. This is different from secondary memory that is a long-term storage. This is where you save the programs for future use. In primary memory, this is where the programs are loaded into. It's also where the data associated with the programs exist. To best understand this, simply remember that memory has addresses that reference these values. Every time you store elements of a program inside of memory, it can be accessed using the addresses which hold the values. Now, putting all of this together, whenever we run software, what happens is you have your program stored on your hard drive, the secondary memory. This is then loaded into your main memory. From there, the main memory is accessed by the CPU and it runs the code. Now, also, the CPU utilizes the memory to store information related to the program. And it continues this loop until the program has been terminated. The other element of a computer is its software. Now, the software is a means for us to implement algorithms to work on a computer, and an algorithm is a set of instructions to solve a problem. However, we are programmers, so we're creating a program which is a little more specific. Now, this is a set of instructions for a computer to follow. Now, in order to develop these programs, we have to utilize what's called a programming language. Now, these are used to develop software, and the way that you can think about it is it's just like a normal language, except what you're doing is communicating with the machine. Now, there's a lot of programming languages out there, and you can usually classify them into two major categories. The first one is low-level languages. Now, a low-level language is as close as you can get to the hardware. The way you can think about this, and two of the major ones that we use, is called machine code and assembly. Your processor only understands zeros and ones, on and off. It only understands binary code. Machine code is binary code. Assembly is a little step up from just machine code, and it starts introducing more natural operators that utilize the CPU. One thing to also keep track of is everything is zeros and ones inside of your system. Therefore, everything is a number. Now, low-level languages are useful and they're very fast as they utilize directly the hardware, but they can be fairly difficult to use. Now, this is why later on, high-level languages were developed. Now, a high-level language is meant to mimic a natural language, and there's a lot of different high-level languages out there: Java, C++, C#, Python, all of those. And all of these are meant to just act like a natural language. There's really no difference, because from a programming high-level language to a natural language, you have things like nouns and verbs. And being able to recognize that helps with solving these problems. Now, much like a natural language, high-level and low-level languages have a very specific kind of syntax. This is the structure that we have to follow in order to communicate effectively with the machine. Now, with high-level languages, there is an extra element before we can actually start running the code. There is another piece of software called the compiler that sits in between. So what we end up doing is we develop the source code, run it through the compiler, and then the compiler converts it into something that the machine can understand. In this course, we're going to be using the high-level programming language Java. Now, to also understand this, we need to go over some basic organization, so some of the basic syntax of the Java language. Now, when developing a solution in Java, it's best to first start by creating a project. From there, Java makes you organize everything first inside of a structure called a class, and then the actual functional code is written inside of another structure called a method. Now, more specifically with Java, the source code files end with the .java extension, and Java makes a very specific rule. The file name has to match the name of the class inside of the file. If you don't do this, this creates what we call a syntax error, and effectively your code will not run. Now, once again, everything in Java is organized class first, then by methods. And that indicates that everything in Java is an object. Now, in order to develop and run Java code, we need to separate it down into two parts. There is the compilation step and then running it. So when we develop the Java source code, in other words, all of those classes that end with .java, we then, much like before, run it into a compiler, a Java compiler, and more specifically in Windows, it's called javac.exe. Now, the Java compiler does not create an executable. What it instead creates is what's called intermediate bytecode, or bytecode for short. And these are denoted by the extension .class. Now, once we compile the code, we can start running the software. But in order to run it, we have to utilize another piece of software called the Java Virtual Machine, the JVM. Now, the way that you run Java software is you take that intermediate bytecode, load it on top of the Java Virtual Machine, and then that is what runs the code. Now, just like the Java compiler was the javac.exe in Windows, running Java is just java.exe. It's a different program. In order to run your program, you have to then load the bytecode on top of the Java Virtual Machine, which is running on the computer. Now, this intermediate step causes the biggest detriment to the Java language. The Java programming language is considered kind of slow because you have that step. But Java's main focus is portability. So when you develop something in Java, and thereby creating those intermediate bytecodes, you can move that code to pretty much any operating system, almost any architecture, and it will just work. Now, when you have something that is very specific to the hardware and the architecture, you can only develop that program for that operating system, for that architecture. If you wanted a fast language, Java may not be the best choice, but if you wanted a portable language, Java's a great choice. And this is an example of a trade-off that we see a lot in computing. So now let's go ahead and start developing a very simple Java program. What we have here is what's called an Integrated Development Environment, an IDE. And what I'm going to be using throughout this class is the IDE called Eclipse. So let's begin. Let's create ourselves a new Java project. Now make sure you give this some sort of meaningful name, and we're just going to start off with a very simple Hello World program. Now once I've named the project, I'm just going to go ahead and click Finish. And then it comes up with this, are you going to create a module? I would say don't create modules for this class. Now you can see over here, this is where our project is. And we have different folders and that kind of such. Now remembering back, Java organizes its code first inside of classes, then inside of methods. So what I'm going to do is go up to File, New, and I'm going to create a new class. Now this program is going to be something simple, and it's just going to be about greetings. Now I advise to go ahead and keep the package default. That way we don't run into some inadvertent errors. Also, for this one, we're going to include public static void main, as that is the main method. We'll talk about that in a little bit. Once I've done that, I'm going to go ahead and click Finish. And our IDE automatically generates some code for us. Now, one of the first things I do is I usually get rid of this auto-generated comment, fix things up a little bit, but then most importantly, I write my name at the beginning of the software. Now, as you can see, the /*/, this is a multi-line comment. Comments are ignored by the compiler. Comments are extremely useful, and you should comment your code well. In other words, you should describe to a person who is reading the software how the software is working. Now, in relation to multi-line comments, you can also have a single-line comment denoted by the 2 forward slashes. Now, underneath there, but outside of the class, I need to include something that's going to allow for user input. Whenever we do this in Java, what we do is we import a package. And in this case, we're going to import java.util.scanner. This now includes this type scanner that we can use to gain input from the console. And we'll see that in a minute. Now to go ahead and just point this out since I'm right here, notice this is what defines the class. Once again, Java always organizes class then methods. And also notice that the class name matches the .java file, our source code. If this does not match the file name, you will end up with a syntax error. Now also, since I'm here, I need to point out that curly braces, the open one and the closed one, this indicates where the body of something is. In between this opening curly brace and this closing curly brace, this is considered the body of the class. Now, very similarly, this is a method where the open and closed curly braces correspond to the body of the method. Now, this main method is a very special one. The main method is also known as the entry point. It's where the computer knows where to start reading those commands one at a time. So, whenever this is compiled into the intermediate bytecode and then loaded on the Java virtual machine, it starts right here reading these commands and executing them. Let's go ahead and write a very simple command to output something into the console. The way that we do that is utilizing system.out.println. And anything that is in between these parentheses is what's printed to the console, which we'll see in a minute. Now, much like curly braces, parentheses has an open and a closed version. If you're missing any one of these, or you have too many of them, you're going to end up with a syntax error, and that's the same thing for the curly braces. So now we've written this statement, let's see how this works. Inside of Eclipse, we have this little play button right here. Now, the thing is, this runs both the Java C, in other words, the Java compiler, and Java, the JVM that loads all of this on top of it. So by clicking this button, it creates the class file that is then loaded on the JVM and runs it inside the console. So when I hit play, as you can see, this is our console, and it just simply says, "Hello World." This is very simple output to the console, and this is what we're mostly going to be using in this class. However, if we want input, that's a little more complicated, and it relates back to that very first statement that we wrote here. What we're going to do is we're going to set up this object called keyboard. That's type scanner, and we're going to construct this object, tying it together with the standard system input. In other words, what is typed in the console. This object right here allows us to basically scan what is entered into the console, but you can use scanners for things like strings, files, network I/O, a lot of different things. So once we have that, let's just do something simple with this input. I'm going to go ahead and enter down, and I'm going to say with this statement, enter two values, and then I'll add them up. Also, by the way, inside of Java and a lot of other programming languages, a statement is this single command that's denoted by a semicolon. Don't forget your semicolons, or else you will end up with a syntax error. Now that I've done that, let's gather the input itself. I'm going to go ahead and declare int val1. This declares a new variable of type integer. We'll get more into that in a further lecture, but we're going to go ahead and assign that using the equals, and then we're going to utilize our object keyboard by calling keyboard.nextInt. Now once again, what this does is this declares this variable, this integer variable, and then assigns it to the value that is collected from keyboard.nextInt. Going a little further into detail, the scanner is an object type. So what this effectively means is an object has not only values, but functionality built into them. Now by calling the method nextInt, what this does is it reads the values entered into the console and finds the first integer value, and then simply stores it into this value here. I'm going to do the same thing for a second value. I need to declare a value 2, and I'm going to assign that to keyboard.nextInt. Now I've collected these values, I need to calculate the sum of these. So once again, I declare a new variable, and I assign that to value 1 plus value 2. This evaluates this mathematical operation and then assigns it to the variable sum. Now once we have that, let's go ahead and print that out to the console. Let's give it some output. System.out.println. Now I'm going to put a string inside of here. Now a string is denoted by an open and closed quote, and I've been using these before, but I'm going to make this one in a special way. I'm going to first start out, the sum is, put a little space there, and then I'm going to use the plus sign. Now with a string, what this means is anything that follows this is appended to this string. So when we print this out, it's going to print out the sum is, and then we add the variable sum to the end of this. Then we put our semicolon, and as we can see, there are no syntax errors in this program. Let's run it and see what happens. Running this, it prints out hello world. Then it also prints out enter the two values. I'll add them. And let's just add in, let's say 2 and 3. And then it prints out this part right here, the sum is, and appends the value that was found inside a sum right there. In this very short example, there is a lot of details that we're going to further expand throughout this course. And with all that being said, I'll see you next time.